Hi guys, today I thought I'd talk to you a little bit about a technique used a lot in aerosol science called optical tweezers. Now, what exactly are optical tweezers? Well, they use the power of lasers in order to hold a particle stable levitating in the air. They were first researched in the 1970s, but it wasn't until 2018 that they were awarded a Nobel Prize. This was awarded half of it to Ashkin, who developed the optical tweezers, and half of it to a group of biologists who used the optical tweezers. Now, the optical part of optical tweezers means that photons of light are actually used to levitate your object in the air. And it's very similar to when you see sci-fi films or UFO abductions. These tractor beams aren't really quite as unrealistic as you might think, but they do have to be scaled down quite a bit. The theory behind this is that if something is falling, but you're pushing against it just as hard, then it stops falling and it just stays in place. And here you use photons, particles of light, to push against something. So even though they don't have a mass, they do have a certain momentum which can be used to push things. This momentum is really, really small for photons. So the optical tweezers for a tiny particle is sort of like trying to stop a jet from falling out of the sky by throwing loads of ping pong balls at it. For a jet, you'd need to throw about 200 million ping pong balls at it at any point in time, and this is similar for photons levitating a particle. Now, the laser pushes hardest at its edges because it's more intense there, and this always forces things back into the middle of the beam. So this is how you can use the laser to move your particle around, keep it trapped in a certain place, and you can even have multiple lasers moving things together so that they coalesce or get pulled apart. But if you push in the wrong way, then you can quite easily destroy what you're holding, especially if it's a very sensitive biological material. It's very easy to get this wrong. Now, although this is a really cool way of levitating objects, it's not the only way. You can also use acoustic levitation, which uses sound waves to float things, or electrodynamic balances, where you essentially have some big magnets, and in between them you have a charged particle which is equally attracted and repelled from either one, and therefore it gets stuck in the middle. You can also have pneumatic levitation. This uses air blown at the particle to push it up, and if you blow at the same speed as it's falling, then it stays in place. If you get a balloon and a straw, you can try just blowing a balloon in the air and trying to keep it stably levitated. Now you'll quickly see how hard it is to keep it in the same place, and that shows you just how carefully tuned these machines must be. Now, this is all great. We can levitate particles, but why do we care about levitating particles? Well, with really small things, they're very hard to look at, even with very strong microscopes. If they're moving around, then you're not going to be able to look at them at all. So if you can manage to keep them stationary, then you can levitate two things, bring them together, move them apart, move them in conjunction with each other to manipulate them, make them do different things. It allows you to avoid other things getting in the way of your particles. So your particles might interact with the edges of the plate that they're on, but if they're levitating and there's nothing around them, then there's no such interaction. And they're used a lot in biology, especially at the moment with COVID research, to see how bacteria and viruses can survive in droplets once they're expelled out of the body. That is what they were first used for, with Ashkin leaving one on overnight by accident, and he found in the morning that bacteria had started to grow on the levitated particle. These are all very valid applications, but in my mind, the most useful application is that they're really cool.